All right, assalamu alaikum everyone. Let's begin. So we were doing coordinate geometry, and this is going to be the last session that we spend on this before we move on to equation of circle. That's also part of coordinate geometry, but that's kind of a new concept. The questions on that are going to be in another worksheet. The worksheet that I gave you earlier, that only has questions on the concept that we will be doing until today, inshallah. So what have we done until now? We've talked about a lot of these basic concepts: distance formula, midpoint formula, finding gradient of lines, gradient of perpendicular lines, parallel lines. We've talked about these things. We've learned how to find equation of a straight line. We've learned how to solve simultaneous equations, how to find gradient of a line from its equation. We've talked about finding equation of perpendicular. So yeah, we just go through all that. So we've talked about how to find equations of straight line. There are two forms for this: y equals mx plus c, and y minus y1 equals m into x minus x1. We learned how to use them. We learned how to solve simultaneous equations. We learned how to find gradient of a line from its equation. We talked about equations of perpendicular bisector. And then we did some practice questions. In the last couple of classes, we also talked about these properties that we have for the diagonals of different quadrilaterals, like whether they're equal, perpendicular, or whether they intersect at midpoints. We talked about these properties. This was important that for a square and rhombus, the diagonals are perpendicular bisectors of one another. And then we talked about finding areas of shapes using coordinates. Sometimes you have a shape that you can just use. For example, you have a triangle. For a triangle, you can just use half into base into height if you have coordinates given that one of the sides is either horizontal or vertical. However, if none of the sides is horizontal or vertical, you have this shoelace formula that you can use sometimes for triangles, and it can also be extended to other shapes which are more than three sides, for example, for quadrilaterals as well. That's what we talked about in our last session. Okay, now let's discuss one last concept that we need to know about in this topic before we do a couple of practice questions. And then in the next session, we will start circle equations, inshallah. So let's do this last concept that we need to do before we move on, and that is finding angle between lines. Angle between two lines. Okay, so this is also something that you need to know about. First of all, let's talk about this concept: finding angle between a line and x-axis. Finding angle between a line and the x-axis. Let's see how we can figure this out. Let's take an example. Let's say you have a line that looks like this. There's a straight line like this. And we have the x-axis passing through the line like this. So the line is passing through the x-axis in this way. Now, it does not necessarily have to be the x-axis. It could actually be any horizontal line, essentially. So x-axis, or you can say any horizontal line, it doesn't matter. So we have this line. Now, we need to find this angle, the angle between the line and the x-axis. How do you find this angle? Let's think about it. Let's take 2 points on this line. Let's say we have a point here, which is xy, and we have another point here. Let's call this, in fact, let's call one of these points x1, y1. Let's say this is x1 and y1. And let's say this other point is x2 and y2. These are 2 points that we have on the straight line. All right. Now, using these points, if we were to make a triangle that looks like this. So if we make this triangle, it's a right angle triangle. What are the lengths of this triangle? So if you think about the horizontal length, this x coordinate is x2. This first one was x1. So the length of this line is x2 minus x1. All right. And if you think about the y coordinates, you see this is y1 and this is y2. The vertical length is going to be y2 minus y1. Now remember, how do you find gradient of a line? Gradient of the line, or in fact, on this right angle triangle, let's actually use tan first of all. So we need to find this angle theta. How do you find angle theta? Angle theta can be found using tan, right? So we can say tan of theta equals y2 minus y1 over x2 minus x1. All right, that's how you find that. That's how tan is defined, right? Perpendicular over the base, opposite over adjacent. That's y2 minus y1. In this case, opposite length is y2 minus y1. The adjacent is x2 minus x1. Now, does this remind you of something? y2 minus y1 over x2 minus x1. This is actually the formula for gradient as well. So this is actually equal to the gradient. So from this, we actually get a formula that looks like this. Tan theta equal to the gradient. This is a formula that we have that we can use for finding angle between any line and the x-axis. So theta here represents the angle between the line and the x-axis, and not necessarily just the x-axis. It could basically be any horizontal line. Right, because it does, the point x and y1 could be anywhere. It does not have to be on the x-axis. Even if you had another horizontal line, so maybe here, like this angle would also be theta. All right, it will be the same angles, using alternate angles. So, using corresponding angles, sorry, not alternate, or corresponding angles, these angles are equal. So this angle theta that we're getting represents the angle between a line and any horizontal line. Okay, now let's take an example for this. Let's say we have a line that looks like this. So remember this formula now. So this is the formula that we can use to find the angle between a line and the x-axis. Let's take an example. Let's say we have something like this. We have a line that's passing here. We want to find this angle theta. And we know that the gradient of this line is equal to 2. How do you find the angle theta? You can just use the formula that we wrote above. Tan theta equals the gradient, which is just 2. Just take tan inverse of 2. That will give you 63.4 degrees. And that's the angle that you're looking for. Okay. This is the angle theta. So it's just as straightforward as this. Let's take another example. Let's say you have a line like this, and there's a line that passes through this way, and you want to find the angle between this line and the x-axis. Let's say the gradient of this line is given to be minus 1.2. Okay. Now, what's the formula? So remember, we're looking for this angle. Let's say this is theta. What's the formula that we use here? Tan theta equals the gradient. Right? Now, We can say tan theta equals minus 1.2. Just take tan inverse and see what that gives you. This gives you theta equal to minus 50.2. Now, what that essentially means is you are getting this angle here. When we do trigonometry, you'll understand negative angles mean that you're going in the clockwise direction like this. So basically, the angle that you're getting from this is this angle, but the magnitude is 50.2 degrees. That's all that we are interested in. It doesn't matter for now whether you're getting a negative angle or a positive angle. Just make it positive and you say that theta equals 50.2. And that will be your result. You don't have to do anything with this. Just change the sign. Just take tan inverse directly and then change the sign. If it turns out to be negative, the angle turns out to be negative, and that will be your result. So the value of theta, therefore, is 50.2 degrees. That's the angle between the line and the x-axis. Okay. Now, sometimes they specify that you need an acute angle between the line and the x-axis, or you need an obtuse angle between the line and the x-axis. So let's say they specify that you need the obtuse angle between the line and the x-axis. Now you found this angle, and this angle is turning out to be acute. If you had to find the obtuse angle in this case, all you have to do is just subtract from 180 this value 50.2, and that turns out to be 129.8 degrees. So if you were asked for an obtuse angle, you would just subtract this number from 180, and that will give you the result, and that's fine. Okay, that's what you're looking for. If they don't specify whether you want an acute angle or an obtuse angle, now these both angles are actually angle between the line and angles and the x-axis. So you could either use this one or this one, it doesn't matter. Okay, so both of them will be acceptable if they don't specify whether they need an acute angle or an obtuse angle. All right, so that's how this formula works. If you're looking for the angle between a line and the x-axis. Now, what if you were not looking for the angle between a line and the x-axis, but we're looking for angle between any two lines? Right now, one line was horizontal, right? So if one line was horizontal, you could use this formula, tan theta equals gradient for that. But what if you're looking for angle between any two lines? Let's think about that. Angle between any two lines. How do we figure this out? Now, again, let's say we have two lines like this. We have one line that's going like this. I'm sorry, draw that again. You have one line like this, maybe something like this. And you have another line, which is going like this. You have these two lines. The gradient of the first line, let's say, so let's call any one of them L1. Let's say this is L1, this is M. The gradient of this line is 0.5, let's say. Let's call the other line L2. Let's say the gradient of this is represented by M2, is denoted by M2, and that value is 2. So the gradient of the first line is 0.5 and the gradient of the second line is 2. We want to find the angle between these two lines. So essentially, we're looking for this angle. Either this angle or this angle, both of them could be angle between lines. You could find any one of the two. All right, the other two are actually equal. So this would be equal to this one, and this would be equal to this one. So it's either this acute angle or this obtuse angle. So you want to find one of these two angles. Now, how do you figure this angle out? Now, one idea is to use the same formula that you used above. All right. But for that formula, you needed a horizontal line. So what you can do is you can draw a horizontal line at the point where the two lines are intersecting. So you draw a horizontal line here like this. And then what you say is, since you're looking for this angle in the middle, you can find this angle between the horizontal line and L2. Let's call this theta 2. And then subtract from this the angle between the horizontal line and L1, that will be theta 1. So if we just find theta 2, subtract from that theta 1, that would leave you with this angle theta. So that's the idea that you can use here. Okay. So what's the formula? Remember, the formula that we did above was tan theta equals gradient. So for theta 1, we could say tan of theta 1 equals 0.5. That will give you some value of theta. Theta 1 turns out to be 26.56 from this. Do the same thing for the other line. Tan theta 2 equals 2. And theta 2 turns out to be 63.43 in this case. All you have to do now is subtract these two angles, find the difference between these two angles, and that will give you the result. Theta equals theta 2 minus theta 1. That's 63.43 minus 26.56. That will give you the result. This turns out to be 36.9 degrees. And that's the angle between these two lines. All right. So that's how you can use that earlier formula, tan theta equals gradient, to find angle between two lines. You find the individual angles with the x-axis, and then just find the difference. Now, in this case, both the lines had a positive gradient. What if the lines had a negative gradient? How do we think about that? So let's say we have one line like this, and we have another line like this. Let's say this is L1, and the gradient of this line L1 is equal to -1. And this is L2, the gradient of this line is -3. Okay, so these are two lines. We have their gradients. Now, what we want to find out is the angle between these two lines. Again, what you can do is, what we can start with is, let's draw a horizontal line at the point where they're intersecting. What we're looking for is either this angle or this angle. Any one of them works. If we have one, we can find the other by subtracting that from 180. So we need any one of these two angles. All right. Now let's try to figure this out. Let me use different colors for this again. So what we're looking for is this angle theta. That's what you want to figure out. All right. Now, how do we start? Again, find theta 1 and theta 2. Okay, so theta 1 would be this angle, and theta 2 would be this angle. All right. Let's see what they turn out to be. Tan theta 1 equals -1, and that will give you theta 1 equal to -45. Now, what you're going to do here is you're not going to change the signs. Okay, keep them as they are. Keep them as they are. Don't change the signs. You'll realize that when we do the next example. In this case, even if you change it, you get the same result. But I would recommend that you do not change the signs. Just keep them as they are. So you have -45, and the other turns out to be tan theta 2 equals -3. That gives you theta 2 equal to tan inverse of -3, which is going to give you -71.56 degrees. How do you find theta now? You can just subtract the two angles. Okay, just keep the signs as they are. It doesn't matter. Even if you don't know what the figure looks like, just apply these formulas and find the difference between the angles. Let's see what that turns out to be. In this case, that's -71.56 minus -45, and see what that gives you. This is giving me -26.6. Once you're done with this, at the end, you make this positive and it becomes 26.6 degrees. And that's the angle between those two lines. That is what we were looking for. Okay, so just apply that formula individually in both the lines and then find the difference, and that will give you the result. All right, let's move on. take another example. Let's say we have a line that looks like this, and we have another line. So this is one line, and we have another line which is going like this. All right. Now let's find the angle between these two lines. Again, we are either looking for this angle or this angle, right? One of the two angles. Let's say the gradient of this line on the right side is 2, and the gradient of this line on the left side is, let's say, -1. We're looking for the angle between these two lines. What do? We have this horizontal line. Let's find the angle between these two lines and see what that turns out to be. So let's say we're looking for the angle between these two lines, okay? Now, how do you find that? Just do the same thing that we did before. Tan θ1 equals -1 and tan θ2 equal to 2. Just find the individual angles with the x-axis. I think I've written it the other way around. Let me write tan θ equal to 2 here. Yeah, okay, let me just change this. Reverse the order. Tan θ1 is actually 2. It doesn't really matter, by the way, which one you call θ2 or θ2. θ1, it doesn't matter, but in this case, we had called this M1. So let's have θ1 corresponding to M1. So tan θ1 equals 2 and tan θ2 equals -1. Let's find the values of these angles that we get from this. So θ1 turns out to be 63.43. And θ2 turns out to be tan inverse of -1. That would be -45 degrees. Now, again, all you have to do is just do this directly. Theta is just going to be θ2 minus θ1. Don't change the sign yet. Keep the sign the same. So it becomes θ2 is -45. So that's -45 minus θ1, which is 63.43. And that gives you minus 108.4. And that means the angle is 108.4. So only change the sign at the very end, in the last step. Okay. That's the angle between these two lines. Now, it might not make a lot of sense where these values are coming from. So basically what's happening is 63.43 is the angle of this line with the x-axis. So you're getting this angle here. This is 63.43. All right. And the other angle is -45. So that is basically representing this angle. This is 45. All right. So you're getting this whole angle. That's why it's coming out to be obtuse. Now, if they have not if they do not specify whether you need an acute angle or an obtuse angle, this is fine. 108.4 as the result is as the final answer is perfectly okay. If they had specified, let's say, find the acute angle between these two lines, how would you find that? You would just subtract this from 180 minus 108.4, and that would give you 71.6, and that will also be okay. This is also okay. This is also okay. It depends on whether they specify in the question that you need an acute angle or an obtuse angle. Okay, so if they specify, this is what you do. All right. Remember, we don't change the signs in the working. We keep them as it is. When you subtract them using the same signs, you could also subtract the other way around. That's also okay. You could do 63.43 minus 45. And that would give you 108.4 as well. And that's okay. But you don't have to change the signs. Don't make -45 plus 45 before subtracting. All right. So this is how you can find angle between any two lines. This is one way to do it. if you just remember this formula, tan theta equals gradient, remember this formula is for finding angle between the line and the x-axis. If you want to use it for two lines, you would use this formula twice and then subtract the angles that you get as the result. Now, there's also a direct formula for angle between two lines. There's also a direct formula for finding angle between two lines. If you can memorize that, you can use that directly, but you have to make sure in that case that your memory is good and you will not mix up the signs here, okay? In case you're sure that you will not mix up the signs and you can remember this exactly as it is, then you can use this directly. The earlier formula is easier to remember because that's just tan theta equal to gradient. But if you want to find the angle between any two lines directly, there's a direct formula for this, and that looks like this, okay? Now, it's actually coming from that same idea. What we did above, this formula actually comes from that same thing, okay? So we will be doing some tan identities later. We'll be doing something like this: tan of A minus B equals tan of A minus tan B divided by 1 plus tan A into tan B. This is a compound angle identity for tan that you do in paper 3. This formula actually comes from that, all right? So it uses this previous formula. It uses this previous formula, and then when we do the subtraction and simplify that, it can be converted to a form like this. So you can actually use this formula directly if you want, if you can memorize this. In this form, theta represents the angle between any two. Okay, angle between any two lines. M1 and M2 are gradients of the two lines. Okay, M1 and M2, they represent the gradients of the two lines. Now, for instance, if you were to use the same example that we did above, in which we had one gradient that was 2 and the other was -1, let's use this formula on that previous example. So this is another formula that we have now that we could use. M1 was equal to 2 there, and M2 was equal to -1. These are the two lines that we had above. All right. Now, if I were to use this formula directly to find the angle between those two lines, this is how it would work. Tan theta, that equals M1, which is 2, minus M2, which is -1, divided by 1 plus M1, which is 2, into M2, which is -1. And that gives me tan theta equal to 3 in the numerator and -1 in the denominator. So we have tan theta equal to -3. And now we can just take tan inverse of this and see what that gives us. That's giving me -71.6 degrees. If we make it positive, that's 71.6 degrees. That's the angle between those two lines. That's the acute angle. If you had to find the obtuse angle, you would just subtract this from 180. 180 minus 71.6, and that would give you 108.4 degrees. And these were exactly the same angles that you found above using that other method as well. Okay, so you could use this formula directly in this way. If you can memorize this, you can use this directly. This gives you the angle between any two lines. All right, I hope that makes sense. Now that completes everything that we had to do in this topic in terms of concepts. Now we will do some more practice questions, but I'm actually running out of time right now. So we'll do a couple of more practice questions in the next session, and then we move on to equation of circle, inshallah. All right, so that's it for today. I'll see you again in the next session.